Tangents to circles. If we think back to M4, we know that a straight line which just meets the circle at any point is called a tangent. And the angle between a tangent and a radius is always a right angle. Consider again the circle with centre 0, 0 and a tangent at a point x, y. The gradient of the radius, now if we think back to gradient, it's found using this formula, y2 minus y1 over x2 minus x1. The other way we think about that is that it's rise over run. So if we look at the coordinates, it's going to be y take away 0 over x take away 0, which simplifies to y over x. So that means the gradient of the radius is y over x. Now, if we wanted to work out the gradient of the tangent is perpendicular to the radius, and perpendicular gradients are the negative reciprocal of each other. So the reciprocal turns a fraction upside down, so it's going to be x over y, and because this is positive, the negative reciprocal is going to be the negative x over y. So that means that the gradient of the tangent is minus x over y. And for all the circles that we'll be dealing with this year, they all have the equation x squared plus y squared equals r squared. So that means their centre is always going to be 0, 0. So that means the gradient of the radius is always going to be y over x, and the gradient of the tangent is always going to be minus x over y. So whatever those xy coordinates are, that's what that's going to be. And then once we've got the gradient of the tangent, then we can substitute that into the equation of a straight line, y equals mx plus c. We'll have the gradient, we'll have an x coordinate and a y coordinate, so we can work out this corresponding c value. So we can work out the equation of the tangent. So example 12, find the gradient of the tangent of the circle x squared plus y squared equals 25 at the point 3, 4. So what we've just learnt is that the gradient of the radius is going to be y over x. So at the point 4, 3, it's going to be 4 over 3. And from that, the gradient of the tangent was minus x over y, and that's going to be minus 3 over 4. So the second example here, the first thing we might want to do is divide the equation by 2, because for our circles they need to be the form x squared plus y squared. So if we do that, we'll get x squared plus y squared equals 324. So the gradient of a tangent is minus x over y, which is the minus of minus 5 over 12, which is 5 over 12. To work out the equation of the tangent, so the equation is going to be y equals mx plus c. The gradient is 5 over 12. The x value is minus 5. The y value is 12. And we don't know c, but we're going to try and find that out. So 12 is going to equal, so 5/12 of minus 5 is minus 25 over 12 plus c. We'll move the minus 5/12 to the other side, and it'll become positive. Now 25 over 12 is 2 1/12, so whenever we add that to 12, we get 14 1/12 is equal to c. So that means the equation of the tangent is y equals 5/12 of x plus 14 1/12. Example C, circle has equation x squared plus y squared equals 20. The point 2, 4 lies in the circumference. Find the gradient of the tangent. So the gradient of the tangent is minus x over y, which is minus 2 over 4, which is minus a half. Part 2, we want to find the equation of the tangent. So the equation of the tangent is a straight line, so it's y equals mx plus c. Our y value is 4, the gradient is minus a half, the x coordinate is 2, and then plus c. So 4 equals minus a half of 2 is minus 1 plus c. So take the minus 1 over, it becomes 5. So 5 is equal to c, so the equation of the tangent is y equals minus a half of x plus 5. Part 3, find the coordinates of the point where the tangent at P meets the x-axis. So whenever we have something meets the x-axis, if we think about that, so the coordinates on the x-axis, we get 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, minus 5, 0. All the y values are equal to 0. So what we need to do is let y equal 0 for the tangent equation. So our tangent equation is y equals minus a half x add 5. When y is 0, we get 0 equals minus a half x add 5. Let's take the x over, and we've got a half x equals 5. And then either dividing by a half or multiplying by 2, we get x equals 10. So the coordinate of the point where the tangent at P meets the x-axis is going to be 10, 0. Example D. A circle has an equation x squared plus y squared equals 40. The points A, 6 minus 2, and B, minus 6 minus 2 lie on the circumference. Tangents are drawn to the circle at A and B. Find the equation of the tangent A. So to do that, we have to work out the gradient of the tangent first of all. So the gradient of the tangent is minus x over y, which is equal to minus 6 over minus 2. The 2 minuses cancel, so you're left with 6 over 2, which is 3. So at A, the gradient of the tangent is 3. To work out the equation, we do y equals mx plus c. The y value is minus 2. The gradient is 3, and the x value is 6 plus c. So minus 2 equals 18 plus c minus 20 equals c. So if I take 18 to the other side, it becomes a minus 18, which combines with the minus 2 to give minus 20. So the equation of the tangent at A is y equals 3x minus 20. For part B, find the equation of the tangent at B. So the gradient of the tangent is minus x over y, which is minus 6 over minus 2. So if we think about the minus 6 over the minus 2, that's two negatives, so the answer is going to be a positive. 6 over 2 is 3, so this part is 3, but we've got another minus, so the gradient of the tangent here is minus 3. So same technique as before, y equals mx plus c. The y value is minus 2, the gradient is minus 3, the x value is minus 6 plus c. Minus 2 works out to be 18 plus c, and then take that over, we get minus 20 is equal to c. So the equation there is y equals minus 3x minus 20. For part 3, to find the coordinates of the point where the two tangents meet, what we're trying to do is really solve these two equations. So we've got an equation of y equals 3x minus 20 and y equals minus 3x minus 20, so we want to try and solve those. So we can do so with a simultaneous equation. Now the best way to do it in this case is a method of substitution. So I know that y from the first equation is 3x minus 20, so if I substitute that into the second equation, I get 3x minus 20 equals minus 3x minus 20. So instead of writing y, I put in 3x minus 20. And then I can solve this. So if I bring the minus 3x over, it will become a plus 3x, which means I've got 6x minus 20 equals minus 20. And then to get rid of the minus 20, I'll move it across and it'll become a plus 20. I'll get 6x equals 0, which means x equals 0. So x equals 0 is the x coordinate. We need to work out the y coordinate, so we can substitute that into either of the highlighted equations. So let's put it into this one, and we get y equals 3 times 0 minus 20. So y equals 0 minus 20. So y equals minus 20. So the point where the two lines meet are 0, minus 20.